I live? I am live. Hey guys, so welcome to our day 5 of a stream. I bet you guys weren't expecting me to stream so late in the night, but programming waits for nobody, right? Today is going to be a short stream. Also, I'm going to try to speak a little quieter because everybody else is sleeping. And yeah, but I'm super excited about our tic-tac-toe tutorial, and I figured that we might as well continue on the tutorial, because if we don't continue the tutorial, then we will not be making good progress. So let's get to it. So today, like I said, might be adjust the microphone, might be too loud. Okay, so yeah, today might be a little bit of a shorter stream because it's really late over here and I don't want to speak too loud to wake my family. All right, where were we? Okay, so I think we were at the point of the tutorial where we made 9 squares over here. As you can see, we still have our 9 squares. This is the same application from last time, and I have not touched it since yesterday. You can see that our 9 squares are still here. We can click on them and they will pop up like the tutorial said. So the last thing that the tutorial told us to do was to lift the state of the state machine, right? Just a reminder, how did each box know that we clicked on it, and how did it maintain the state? Well, in order for the box to have maintained the state, it needed to keep track of the variable like clicked, right? The value, right? We need to keep track of the value. So in order to keep track of the value, we set up a state handler, and we put it into the square. Now, a side effect of handlers is handlers don't remember across components. Handlers only remember within the component itself, right? So if we want different components, subcomponents to work together, you can't have the states like separate states in each of them. You need to use the parent state to control the smaller components, right? Like a puppeteer master. So that's where we're at with the tutorial. Let's take a look. Let's zoom out a little bit. I think you guys can still see at this zoom level. All right, so lifting the state, right? Currently, each square component maintains a part of the game state. To check for a winner in the tic-tac-toe game, the board will need to somehow show the state of each of the 9 square components. How would you approach that? At first, you might guess that the board needs to ask each square for that square state. Although this approach is technically possible in React, we discourage it because the code becomes difficult to understand, susceptible to bugs, and hard to refactor. Instead, the best approach is to store the game state in the parent board component instead of each square. The board component can tell each square what to display by passing a prop, like you did when you passed a number to each square. To collect data from multiple children, or to have 2 child components communicate with each other, declare the shared state in their parent component instead. The parent component can pass the state back down to the children via props. This keeps the child components in sync with each other and with their parents. Okay, so lifting the state into a parent component is common when React components are refactored. That makes sense. Let's take this opportunity to try it out. Edit the board component so that it declares a state variable named squares that defaults to an array of 9 nulls corresponding to 9 squares. Okay, so the state of the system is, okay, so remember that when we declare a hook with use states, inside the parentheses is our initial condition. So what this is saying is it makes an array of 9 and then fills it with null. So array of 9 fill null creates an array with 9 elements and sets each of them to null. The useState call around it declares a square state variable that's initially set to that array. Each entry in the array corresponds to the value of a square. When you fill the board in later, the square array will look like this. Okay, so you guys can see that we're using a linear list to keep track of this two-dimensional information, which is fine because it's actually, you can flatten this into like a single line, right? From 1 to 9. Okay, so let's do that on our application. So we're gonna go to our useState over here, right? And we want to move this to board. Right? We don't want this in square. We want this in board. And we're going to move it to board. Okay, great. Now we have an error because now set value no longer exists and value also no longer exists, which is fine. Also, I don't remember why we have two random. Why do we have two random components over here? I don't think that I don't remember putting that there, but maybe my memory fails. So, okay, so let's just ignore this error right here. Let's just do what the tutorial says. So it says, let's make an array of 9 elements and then fill the array with null. To be honest with you, this JavaScript convenience function seems really it seems super useful because it's so readable. Okay, great. And let's see. So the square needs to, okay, so what are we doing again? Okay, so the square is going to display a value, right? I wonder if did we modify? Okay, we have not. Okay, so great. So it says we're gonna add to the board component. Oh, I'm sorry. We should not have copied and pasted it. I know that we're probably gonna delete this in the future, but let's just follow the tutorial. So let's just keep the original for now, right? So make sure it still works. Okay, it still works. And then what the tutorial tells us to do is to create a new state inside board. So how do you create a state? First, you make a constant so nobody can write to the variables. Then you make a constant array of squares and set square. Okay, and then we make that equal to useState. And then this is the initial condition, which is the array of 9. Fill it with null. Great. Okay. Now we're going to pass the prop down to each square. Okay. It's easy enough. So what did they name the prop? They named the prop value. Okay, that's fair. I mean, that's what we want the square to display, a value. And the value, what's each square going to display? Well, it's going to display whatever square is in whatever squares has, but okay, I'm spelling everything wrong right now. Okay. And what are we missing? We're missing parentheses or curly brackets. Okay, great. So why did we do this, right? This is because array 9 fill null creates an array of 9 sections, right? So null, blah, blah, blah. Creates 9 of these, right? Each one of these represents one square on the board. So the first square is going to be the 0th element, right? The second square is going to be the second element, and so on. You just keep adding these. Right, so that's the first three. Let's just make sure this works. Right, so we're gonna go here, we're gonna add value here, because that's how you add a prop. So in order to add a prop, we did this earlier on in the tutorial, right? But to add a prop, you go like this, you remove this guy, because it no longer is a what you will call it, it does no longer has a state. Right, so let's see, handle click is not defined. That's fair, because we don't care about the clicks for now. Let's just remove this. Great. So right now it displays nothing because we filled the array with nulls, right? Let's fill the array with like hello. Bam. So you notice that the first three squares has hello filled in because the initial condition was hello, right? And we only updated 3 of the squares to reflect the value. So let's keep going. You'll start to see that all the boxes will be filled up by the time we're done. Okay, great. So 0 to 9 elements, they all have hello because we all filled them up with hello, right? So I'm assuming that now we're gonna have to add an on-click component as well, or an on-click prop. So it's we're probably gonna make a handle click button or a handle click function, right? So let's make a function. The function will be handle click, right? Because we needed to handle the click. And what does it do? When we click the button, when we click the square, we are going to update squares. Okay. But now we have to update the correct square. Haha. So I guess the function needs the square number. Okay. Since it's already pretty late, usually I would try to implement it on our own. All right, let's just do it real quick. Let's try it out. So we're gonna give it like a variable, right? A parameter. The parameter is gonna be the square. Okay. And then we're gonna say squares, right? So what do we need to do? We need to, okay, so let's start from the top here. So essentially we're gonna have a prop that says on click, right? Like this, and then we're gonna pass handle click, right? And then when we pass handle click needs to know the square. But here's the problem. Okay, let's just follow the tutorial because I'm a little too tired to figure this out right now. Okay, so as the tutorial said, put the squares in. The squares are displaying now. Next, you'll edit the square component to receive the value prop from the board component. This will require moving the square's own stateful tracking of value and the button's on-click prop. Okay, that's what we already did. So now it's empty, right? Great, that's what we did. Each square will now receive a prop value that will be either x, 0, or null for empty spaces. Okay, next you need to change what happens when the square is clicked. The board component now maintains which squares are filled. You'll need to create a way for the square to update the board state. Since the state is private to the component it defines, you cannot update the board state directly from square. And instead, you'll pass a function from board component to the square component, and you'll have square call that function when the square is clicked. You'll start with the function that the square component will call when it is clicked. You call that function on square click. Okay. Okay, so that's kind of what we did, right? So let's see, on square click. Okay. Now we're gonna add on square click to the squares component props. Okay. Now you'll connect the on square click prop to a function in the board component that you'll name handle click. To connect on square click to handle click, you'll pass a function to the on square click prop of the first square component. Okay. So lastly, you'll define handle click function inside the board component to update the squares holding your board state. Okay, so let's see what's happening here. So, oh, I see how this works. Okay. The handle click function creates a copy of the squares array with the JavaScript slice array method. Okay, so it creates a copy of squares. Then handle click updates the next square array to add x to the first square. Okay. Okay, so JavaScript. Okay, so this is the thing I was a little confused about. So I guess JavaScript supports closures, which means an inner function, handle click, has access to variables and functions defined in an outer function board. The handle click function can read the square state and call the set squares method because they're both defined inside the board function. Okay, interesting. So closures, let's see what a closure is. Combination of functions bundled together with references in the surrounding state. In other words, a closure gives you access to outer function scope from an inner function. JavaScript closures are created every time a function is created at function creation time. So consider the following example. You have a constructor named Mozilla. You have a display name, and it calls init. Okay. Init creates a local variable called name and the function called display name. Display name is an inner function that is defined inside init and is only available within the body of the init function. Okay. Note that display name function has no local variables of its own. However, since the inner functions have access to the variables of outer functions, display name can access the variable name declared in the parent function init. Oh, I see. Okay. Okay, so that makes, okay, so that's closure, I guess. So you see how name is defined outside of display name? We didn't have to pass it in as a variable. The scope includes this whole outside function. Okay. Okay, so there is some scoping with let and const. Let's take a look at that. Oh, actually, let's not take a look at that now. Take a look at it in another day. Consider the following example. So the name is outside. Okay, so we can use the name. Now when you do make func, okay, so running this code has exactly the same effect as the previous example init function above. What's different and interesting is that the display name inner function is returned from the outer function before executing. Okay, so what's this saying? Display name inner function is returned from the outer function before being executed. Okay, so is returned. Oh, I see. Okay, so we returned the function, right? So we just sent a function out. Okay. And then, oh, wow. and then they called the function. Okay, so at first glance, it may seem unintuitive that this code still works. In some programming languages, the local variables within a function exist just for the duration of the function's execution. Once make function finishes executing, you might expect the name variable to no longer be accessible. However, the code still works as expected. This is obviously not the case in JavaScript. The reason is functions in JavaScript form closures. Okay, interesting. A closure is a combination of a function and the lexical environment within the function that was declared, with which that function was declared. This environment consists of any local variables that were in scope at the time the closure was created. In this case, myfunc is a reference to the instance of the function display name that is created when makefunc is run. The instance of display name maintains a reference to its lexical environment within which the variable name exists. For this reason, when myfunc is invoked, the variable name remains available for use and muzzles passed to console. Okay, so that's very interesting. So, okay, with this in context, this means that we can basically make a function, return the function, and then all these things will still exist as long as it's in the scope of this function, right? As long as this function basically, wherever this was declared, everything outside that scope still exists. Okay, so how does that apply to here? Well, actually we're using closures because we're doing the same exact thing. So how is it that we're doing the same thing? So we're passing functions. Yeah, we're passing on click, square on click. Okay, right. So we're passing handle click, which we created inside a board. Right here, handle click, we created this. So we're passing this through to the square. And so when this function is created, it has the scope of everything. So it has next squares, it has all this stuff. And then the square, inside square can use that function with all of the variables included, right? So this is quite interesting, actually. And that's how you pass information down to components. Huh. Okay. So why is this code? Oh, I see. So next square is you take a slice of this thing. Set next square. Set squares. Next square is x. Okay. Oh, I see. Okay, so why did we need to do this? So it says we took the next squares, we set next squares. Okay, so it creates a copy of the squares array with the slice array method. Okay, that makes sense. It's no longer referenced as a copy. Why did they do that? Oh. When I change this will trigger re-render that uses the square as well as the child component. Ah, okay. All right, so quick test, guys. Quick test. Wait, but this is a constant. Can you modify constants? That's the question. So let's ask ChatGPT. Oh, okay. I did not mean to re-ask ChatGPT, but we did, so that's fine. So, dear ChatGPT, when we define a const variable JavaScript, can we change the content of that variable? We can. We can, so I don't know why we needed to slice it. Okay. cannot change the reference, but what? Oh, interesting. Oh, we were asking about constants earlier. That's why it's okay. So essentially, we were asking ChatGPT about constants in the last, like yesterday, and when we asked it a new question, it assumed that we were asking about the previous question. That's fine. However, const doesn't make it immutable. Okay, that makes sense. So the data is not static. I mean, the data is not immutable. It's just a constant. Like the pointer is just constant. If the variable holds an object or an array, the things inside the array or object can be modified. Okay. Okay, so we can modify it. I wonder why we have to slice it. Let's ask ChatGPT this. In the React tic-tac-toe tutorial, why do we need to slice square instead of just modifying the square list, the square array? And we're gonna stick the tutorial in there. Okay. So it's recommended to treat a state as immutable and avoid directly modifying the state. Okay, that's fair. But what it said that when we call set state, it knows that we changed the state. Okay. Okay, so this can properly recognize. Okay, that's fair. Okay. Great. But the tutorial says that if we call set state, React knows to retrigger a render. Not set state, I'm so sorry. Set squares. Calling set state with a new state does retrigger a re-render. React compares the new state value with the previous state value. If they're different, the component, it'll update the corresponding UI. The use of slice may not be necessary for triggering the re-render itself. It is primarily used in this case to create a new copy to maintain immutability and ensure proper state management. Try creating a new copy of the array using slice. By creating a new copy, you avoid directly modifying the original state. This is important because React relies on detecting changes in state references to determine when a re-render should occur. Okay. Okay, so I guess it's just good practice not to modify things directly. All right, so now that we've gone on our little adventure trying to learn about closures and what were we just trying to learn about, why we're slicing things, let's try to continue the tutorial, right? So how long have we been streaming? Half an hour? Okay, so let's finish this part real quick and then we can keep going. Okay, so the first part is we want to add an on square click to our button. Okay, right here, this is our button. We're gonna do on click and we're gonna give it on square click. Okay, and then as part of the prop, we're gonna be able to pass in on square click. Cool. Now over here in the board, we're going to do on square click. On square click, it's going to call handle. Let's make a function. Call handle click. All right. And then we're gonna pass handle click down here. And this function is not very happy. Why is it not happy? Because I tried to declare a function with curly brackets. Cool. So now what's the problem? Cannot assign a read-only property a message expected. Okay, so clearly I am making typos everywhere. Great. Okay, so this is kind of what the tutorial told us to do. So we added on square click over here to the square. Right? Did we do that? Yep, on click. So on click, it's gonna call this function. This function is gonna not call the function, but it's literally going to what do you call it? Operate, like perform. It'll perform the function, right? It'll like execute the function instead of just passing the reference. It's gonna do the function, right? So that function is on square click, and then we're gonna handle click over here. Handle click is right. So we added it as a prop, and then we said, hey, on square click, you handle the click. Great. And then here's the logic for handle click. So we're gonna create a new slice for squares. We'll make a shallow copy, then change the 0th square, and then set the square. Okay, so that's not too bad. That's doable. Understandable. So we make a new const. We call it next squares. I don't know why they called it. Oh, okay. So they did call it next squares because it's all of the squares. Next squares is equal to squares dot slice. Okay, so this makes a copy. We're gonna change the 0th element of next squares to x. So the first square will have an x. And then we're gonna use our state set, our hook, set squares, and then we're gonna give it next squares. Great. Okay, so what does that do? So that means that anytime we click any button, it's supposed to render an X over here. Okay, does not do that. Why? Because we only added the handler to this one. Ha! Bam. But if we add the handler on another square, what will it do? It probably will, let's refresh this page, add it to the first box, right? Why did it add it to the first box? Because we only modified the first box. So this doesn't say how to figure out which square we're on. I think that's what they're going to talk about next. Let's think about this for a second. Okay, so the solution I'm thinking of is we would pass the square number as a parameter, right? So like pass the square number like 1 over here. But the problem is if you do that, like if you do 1, this will operate. Yeah, right. So this will happen, right? It'll say too many re-renders, right? Because then this will try to perform handle click. So how do we pass information down? I think it's going to tell us that we need to pass it as a second prop. That's what the tutorial is going to say, I'm thinking. So I'm thinking that it's going to say like index or something, or ID, and we're going to put 0. I'm going to put like 0 here. And then when we put 0 there, then this will have an ID. I don't know. Handle click. Does that work? ID here. Whoa. But now the square. So the square knows is ID, but we need handle click to know the square's ID. Okay. Well, basically, this needs a ID over here. All right. So I am going to give up and look at the answer. Okay, so it says you will define handle click. That's what we did. It works. Great. Now you can add access to the board, but only to the upper left square. Your handle click function is hard-coded to update the index for the upper left square to handle. Let's update handle click to be able to update any square. Add an argument I to a handle click to the handle click function that takes the index of the square to update. Okay, so that's fair. That's what we were going to do initially. Great. All right. And then let's make sure we're updating the right square. That's this one. I. Great. Next, what? Next, you'll need to pass that I to handle click. You could try to set on square click prop of the, you could try to set the on square click prop of the square to be handle click 0 directly in GSX, but it won't work. Okay, so they ran into the same issue that we ran into. Here's why it doesn't work. Handle click 0 call will be part of rendering the board component, because handle click 0 alters the state of the board component by calling set squares. Your entire board component will be re-rendered again. But this runs handle click, leading to an infinite loop. Okay, so what does it mean? This will, okay, right, so handle click, this alters the board by calling set squares. Ah, I see. Right, exactly. Why didn't this problem happen earlier? When you were passing on square click, handle click, you were passing the handle click function down as a prop. You were not calling it, but now you're calling that function right away. Notice the parentheses in handle click. And that's why it runs too early. You don't want to call handle click until the user clicks. Right, exactly. So you could fix this by creating a function like handle first square click that calls handle click 0. A function like handle second square click that calls handle click 1, so on. You would pass rather than call these functions down as props like on square click, handle first square click. This would solve the infinite loop. But this defines 9 different functions, giving them a name that's too verbose. Instead, let's do this. Okay, so we're using arrow functions. Okay, so notice that this is a new syntax here. Blah is an arrow function, which is a shorter way to define functions. When the square is clicked, the code after the arrow will run, calling handle click 0. Oh, I see. So we're basically making new functions. So to get around being able to, I see. So it's basically using closures to, all right, that's clever. So this is actually using closures to pass this parameter as part of a new function, like a part of a new function. And when this function is created, the scope, the lexical context is saved too, which is handle click, and then you can pass this as a reference around. That's very clever. When the square is clicked, the code after the arrow will run, calling handle click. Now you need to update all the other 8 squares. Okay. Look at that. It works. All right, so let's try it out. So what do we need to do? So handle click requires an index. Right now it's not going to work because we're not calling the index. I wonder if it crashes. It doesn't crash, but it doesn't do anything because we didn't give it an index. So what are we going to do? We are going to try to break it. So too many reminders. This calls a function. What we need to do is make an arrow function. Okay. And this arrow function we'll call handle click 0. So this seems to work. Does it work? And voila, it works. So all we need to do is do that for every single square. Okay, cool. All right. Seems to work great. So all of our squares seem to work excellent. All right. We learned a lot today, actually. We learned about closures. We learned about arrow functions. We learned how to pass parameters down to props without operating on them so that they wouldn't keep calling itself over and over again. This is really cool. Okay, so let's finish reading this and then so it's gonna talk about immutability. Okay, so we were a little ahead. So now that your state handling is in the board component, the parent board passes the prop to the square child so they can be displayed properly. When clicking on a square, the child square component now asks the parent board component to update the state of the board. When the board state changes, both the board component and every child square re-renders automatically. Keeping the state of all the squares of the component in the board component will allow it to determine the winner in the future. Cool. Let's recap what happens when a user clicks the top left square on the board to add an X. So when they click the top left square, the on-click prop from okay, so when you click it, when you click the button, the on-click prop is called. Clicking on the upper left square runs the function that the button receives in the on-click prop. Okay. The square component received that function as its on-square prop from the board. The board component defined the function directly in JSX. It calls handle click with the argument of 0. Cool. So that with using the arrow function. Handle click uses argument 0 to update the first element from null to X. The square state of the board component was updated so the board and all of its children re-render. This causes the value prop of square component with index of 0 to change from null to X. Okay, that's what we did. In the end, the user sees the upper left square has changed from empty to having an X after clicking it. Cool. So the DOM, there's a quick little note. The DOM element on-click attributes has special meaning to React because it's a built-in component. For custom components like square, the name is up to you. You could use any name to the square's on-click prop board's handle click function and the code would work. In React, it's conventional to use on something names for props which represent events and handle something for functions that handle those events. Okay, so that's just a convention. All right, so this is the last bit and then we're gonna call it quits today. Why is immutability important? This is what we asked ChatGPT. So let's see if ChatGPT got it right. Note how in handle click you call .slice to create a copy of squares instead of modifying the existing array. To explain why we need to discuss immutability and why immutability is important to learn. There are two approaches to changing data. The first one is to mutate the data. So the first one is to change the actual data values. Second is to replace it with a new copy. Okay. So if we changed or mutated the squares array, this is what it would look like. So all of them were null. You change 0. Now the first one is X. Without mutating, you make a copy of it and then you change the copy. The result is the same, But by not mutating directly, you gain several benefits. Immutability makes complex features easier to implement. Okay. Oh, so they want to implement a time travel feature. So if you don't mutate the array, you can basically undo and redo because you have all the states kept track of. Okay. Another benefit of immutability: by default, all the child components re-render automatically when the state of a parent component changes. This even includes the parent components that weren't affected by the change. Although re-rendering is not by itself noticeable to the user, you might want to try to skip re-rendering a part of a tree that wasn't clearly affected by it for performance reasons. Okay. Immutability makes it very cheap for components to compare whether their data has changed or not. Interesting. You can learn about how React chooses to re-render in the memo API reference. All right, so this is actually interesting. It says that by using immutability, it says that all child components re-render when the state of a parent component changes. Okay. This includes even the child components that weren't affected by the change. Although re-rendering is not noticeable to user, you might want to skip re-rendering part of the tree that clearly wasn't affected by it. Okay, so I guess by using immutability, you probably can, oh, I see. So maybe you can make a copy of it. You can make a copy of some state and then only update a part of the state. This part, I think we want to ask ChatGPT. Can you give us an example where immutability allows React to not change the state to efficiently, to not change the state of a certain tree of code? This is from the example. In the tutorial. Okay, so let's see what ChatGPT says. Certainly. Wow. This is crazy. ChatGPT can understand so much. Okay. Imagine you are a parent component that maintains a complex state object with multiple properties and nested data structures. Within the state object, you have a nested array called data that represents a large data set. Okay. In this scenario, let's assume child component 1 uses data to render a specific part of the data set. However, some other child component don't depend on the data prop and have their own independent state. Now, suppose an event occurs that triggers a state update in the parent component. Okay. If the data is directly modified, React would detect a change and trigger a re-render of all the child components. Oh. However, if you ensure immutability and create a copy of data before modifying it, React can perform a reference check and determine that the data prop passed to child component 2 has not changed. As a result, React can skip re-rendering child component 2. By maintaining immutability, React can optimize performance by selectively re-rendering components that changed. Oh, immutability makes this comparison cheap and efficient. It's worth mentioning React provides additional optimization techniques like React Memo and Peer Component. Wow. This is an extremely good example. I'm very impressed. Thank you for helping with my understanding. Honestly, the examples that ChatGPT come out with are really good. Like this is excellent. Now we understand what's happening. So basically, if we just modify data using set data and you make it immutable, it'll just re-render the stuff, right? If we didn't do that, suppose an event occurs, it triggers a state update. I see. If we directly modify data, then it's going to change all the components. If we use set data and we make a copy of it and keep it immutable, then it knows it to only change this one, right? Okay, so that completes our board. We have successfully lifted the state of our system, of our tic-tac-toe game. The state used to be in squares, and now it's in board. And we learned about closures, which is super cool. We also learned about arrow functions, which allow us to pass parameters, like allow us to make quick functions that allow us so we can pass parameters down to props without actually calling them. And we learned about how immutability helps us render only parts of React. So yeah, we actually covered a lot for our stream today. It's been about 50 minutes, so I think this is a good place to call it a night. And I just want to thank you guys for joining me on the stream tonight. It is a little bit later than usual today, but at least we got it done, right? Tomorrow we're gonna continue on with the tic-tac-toe tutorial. We're getting close to being finished, actually. We're almost maybe like a little more than halfway through, almost 2/3 through, I'd like to say. All right, maybe a little more than half. And we're making really good progress. I'm really glad that you guys could join me today. Like I said before, we have a Discord channel that you guys can find the link to. I'll put it on the YouTube description or in the comments of the YouTube video. And please join us on our Discord channel. That way you can join us on the stream. You can talk with me. We can learn together and grow together, right? So everybody have a great night. Yeah, I'll talk to you guys here. So thank you guys so much for joining the stream tonight. Have a great night. We'll continue on tomorrow. And yeah, see you very soon. Join our Discord. Please subscribe, like, comment, do whatever you want to interact with us. Thank you so much. Good night.